Hello and welcome to part 3 3/4. My Mattel Aquarius is fixed. Now you may say, of course it's fixed, you fixed it at the end of part 3.5, which is true. But I had fixed it by replacing my main board with this board that I bought from eBay. And you know, it just wasn't sitting right with me that there was some other motherboard in my Mattel Aquarius. So I thought I would try to repair it one more time. And the trouble turned out to be the CPU. All the trouble we had with the tape drive and the stripes on the screen and then the black screen and the keys not responding, they were all caused by the central processing unit. The Zilog Z80 had gone bad. And this is how I went about repairing it. I posted a link to the last video, part 3.5, to the users group on Facebook. And Mac Wharton was not impressed at all. He wrote, "Wow, please everyone, never ever unsolder chips like that." And then Jay Mundy says, "Thank you," but he says it to Mac.
Shoot that son of a bitch!
Well, no, I didn't take offense. I took his advice. Now, somewhere on this forum, and it's probably buried way down deep because it was a while ago, I read where a guy fixed his computer by replacing the CPU. It might not even have been the Mattel Aquarius forum. It may have been some other forum out there for retro computing. It would be way down here. What was that shoe? It would be way down here, buried somewhere. Anyway, within an hour of posting the last video on YouTube, part 3.5, Retro Tech Nerd 644 wrote in and suggested that I just cut the chip out with pliers and then remove the pins. So then with a few clicks of the mouse finger, I was up on eBay purchasing a genuine Zilog Z80 original equipment manufacturer central processing unit. Here's the main board for my Mattel Aquarius, and there's the CPU, the Zilog Z80. And here's the one I got from eBay. The chip was cut out per the advice from Retro Tech Nerd 644. I could have used some smaller cutters, but this is all I had. And out comes the chip. So the pins started coming out using a soldering iron and needle nose pliers. But I found I didn't need the pliers. If I wet the tip of the soldering iron with some solder, the pins would stick to the solder and just lift out. Here's a bunch of the pins. There were 40 of them. Now I'm attempting to wick up the excess solder with something called solder wick. I had limited success. It did remove some of the solder, but it wouldn't remove the solder from the holes in the circuit board. Now I don't think it was the solder wick, I think it's me. I don't know how to use this stuff properly. I only have one of those spring-loaded solder suckers, and it wasn't useful in this circuit board. The amount of solder was too small. So I'm cleaning the holes in the circuit board out with hot pieces of wire. This is boring and tedious work. You usually have to send the wire through at least twice. When I got done, I had about 120 little pieces of solder-coated wire. Eventually, all the holes in the circuit board were clean, and it was ready for the new CPU. Soldering the chip in proved to be the easiest part of the whole operation. All 80 connections were soldered within just a few minutes. Now we'll remove that board that I got from eBay in the last episode and replace it with my original board, which has new electrolytic capacitors, new RAM chips, and now a new CPU. Let's check the memory and see how good of a job I did replacing those RAM chips with the Mr. Solder Fix method. And there we go. So, is it fully fixed? Remember, the original trouble was that it would not see the data recorder. Alright. We're playing a tape. Will it see it? Come on, baby. You can do it. Come on. Yes! The Mattel Aquarius reports I'm alive and working. Actually, I knew that was going to work. In order to load that program, I first had to save it, which I did off camera. If it didn't work, you wouldn't be watching this video. Okay, now I found another program named Blue, which you may remember, or not, if you saw the last episode. And Microsoft Windows has crashed due to bad picture on analog television. Okay, I've restarted the computer with the 16K memory expansion cartridge. Now we've got 18K, the 16K plus the original 2K. So everything seems to be working fine. Well, I had an interesting time delving into the Mattel Aquarius hardware, and I had some fun. I guess you could call it fun. As long as you're not sticking little heated wires through holes in a circuit board, it's fun. Now, normally you can't even see the hardware because the hardware is hidden behind this RF shield. But everything's working fine now. I wrote this little program to exercise the machine, and it's been running for about an hour. It's called the 3n plus 1 problem, or the Collatz conjecture. The way it works is you pick a number. If the number is an odd number, you multiply it by 3 and add 1. If it's an even number, you divide it by 2. And then you take the result and apply the same two rules. If the result is an odd number, you multiply it by 3 and add 1. If it's an even number, you divide it by 2. And you keep going on and on and on. And the last three digits will always be 4, 2, 1. No matter what number you started out with. Now, it's the Collatz conjecture because it can't be proven. It also cannot be disproven. And I'll show you how this little program works. It's only like a dozen lines, if that. And it has a very interesting output. Here's our program running. The computer picks a number at random, and it applies those two rules. And it will always end in 4, 2, 1. Now, you'll see that it could end in 168421, 168421, but 421 will repeat forever and ever. I just told the program to stop calculating when it reaches 1. Now, it's a little bit clunky the way I wrote it, but it's basically like this. Clear the screen, generate a random number, multiply it by 1,000, and turn it into an integer so that we don't have any fractions. So we want a whole number for the random number. I had two variables named ping and pong, but I found out I couldn't use pong after I typed everything in because the PO in pong is part of the reserved word poke. So pong is now P2. We take our random number and turn it into a string. We look at the rightmost digit of the string, and if it's equal to 1, 3, 5, 7, or 9, then P2, formerly pong, is equal to 1. That means it's an odd number. Otherwise, P2 is equal to 0. That was Andrea's idea to check the last digit. If P2 is even, we divide it by 2. If P2 is odd, we multiply it by 3 and add 1. We print it to the screen, and we go to 70, which says continue doing this over and over until you reach the digit 1. When you hit 1, go back up to 10, start over, and generate a new random number. So I wrote this to exercise the machine, and apparently my Mattel Aquarius is completely repaired. Well, thank you very much for watching part 3.75, or 3 3/4. As I said in part 3, if I ever figure out a way to get information into a Mattel Aquarius from a laptop, I'll make a part 4. Now, if I turn this on, are sparks going to shoot out like last time? When I fix something, it stays.